Hi to all. Okay, in this video we're going to continue again and again until we finish our module 5. And in this video we're going to cover the last subtopic, which is 5.6 microprogram control. It's quite long. It's going to cover the overview, microoperation, microprogram control unit, address generation, micro instruction format, advantages and disadvantages of microprogramming. Okay, the overview. The term of microprogram is an approach to your control unit, your CU, design that was organized systematically and avoided the complexities of hardwired implementations. So that is the purpose of microprogram, which is to an approach to your CU, design and organization systematically and avoid the complexity of your wired implementations. In recent years, microprogramming has become less used but remains a tool available to computer designer. Example, your Pentium 4, most of instructions are executed without the use of microprogramming, but some of the instructions are executed using microprogramming. Means that last processors, Pentium 3 or Pentium 4, you mostly use the microprogramming, but towards nowadays, which is recent years, nowadays it's becoming less to use the microprogramming. A wide variety of techniques have been used for CU. Most of these fall into one of two categories, so we can categorize it into two main, which is hardwired implementation and also microprogram implementations. So only these two, whether it is hardwired and then another one is microprogram. Under hardwired implementation, sequential circuit, the control logic is implemented with gates. This one already touched a bit about your DL, so that's why your subjects throughout what you're going to learn from year 1 to year 4, it's having some connection and correlation between each other. So now if you did not learn about the L before, then you will feel like, oh, what is this, gets, flip-flop and so on. So the control unit is implemented with your basic gets like your flip-flop, decoders, which is your combination circuits, sequential circuit and so on, which is digital circuit. So here is the example of your sequential circuit. No need for me to explain more because this is just example, and throughout you already look into this kind of sequential circuit and many kind of sequential circuit you already been through. So why hardwire is good, or what is the pros and cons if you are using the hardwire, and what is the pros and cons if you are using the microprogram implementation. Now we look into hardwired. Hardwired is fast operations, small, require less component. This is under hardwired advantages, but using hardwire needs wiring change if the design has to modify. So if let's say you are designing like this is your design for your program, but maybe you want to change the design. So all and mostly your wired connection need to be changed. That is the disadvantages if you are applying hardwired implementations. And if let's say you are using micro program implementation, there is also pros and cons. Everything inside this world, you know it that everything has pros and cons. There is nothing in this world that perfect, actually our prospect as well. So over here we're going to look into the pros and cons about microprogram. So systematic and any required change can be done by updating the microprogram in control memory. This is the advantages. But it is slow operations, require more components if you are using microprogram. What is the function? The control information is stored in your control memory. The control memory is programmed to initiate the required sequence of your micro operation. Now we're going to look into the micro operation. To implement a control unit as an interconnections of basic logic elements is no easy task. No easy task. Why it translate it one by one? It is not an easy task. The design must include logic for sequential through your micro operations, for executing micro operations, for interpreting your opcodes, and making decisions based on your ALU flags. It is difficult to design and test just a piece of hardware. Of course, if let's say you have short wires, maybe sometimes you can burning your circuit. The design is relatively inflexible. For example, it is difficult to change the design if one wishes to add a new machine's instructions. If you want to add one only, also it's going to be quite difficult. So this is disadvantages of your hardware implementation. As stated also in this figure, you already see the disadvantages and also pros and cons. Throughout the problem or disadvantages that occur, an alternative to a hardwired control unit is a microprogram control unit. So because you you want to avoid to use the hardware implementation, because you want to reduce the needs of your components, or maybe you don't want to change its the design is very hard, right? So that's why you have an alternative way, which is using the microprogram control unit, in which the logic of the CU is specified by a microprogram, or it also known as a firmware. A microprogram consists of sequence of instruction, which is your micro operation in a microprogramming language. And microprogram control unit is relatively simple logic circuit that is capable of 1. Sequencing through micro operations, and second, generating control system to execute each of your micro operation. What is your micro operation? You already look into I think 5.4. So please make sure you still remember whatever you already learned. How we use the concept of microprogramming to implement control units or CU. Consider that each micro operations, the CU is allowed to generate a set of control signal. So you need to consider these things from I'm going to inform to you and share with all of you. And how about the question? The question will be coming out from module 3 and module 4 only. Kalau you tanya modul 1, modul 2 ada masuk tak? In term of your knowledge, yes. But in term of question, it's not. But maybe of course there is a correlation like what is CPU or what is the function. Dia takkan direct tanya that question. It's going to have like because of that question, it's having your knowledge from module 1 and module 2 only. So all from coming module 3 and module 4. Sekejap Okay, you can see over here. This is the slide for your module 3. Maybe you can start this week to do the some exercise for you on our test 2 upcoming. And there is no yet sharing about past year test 2. So once the Dr. Muhalim said, okay, I can share, then I can share with all of you our past year test 2. Mana ni? Okay. Okay, what you do in your module 2, which is on your basic elements and also assembly language, example adding, subsetting, defining data, symbolic constant and so on. So over here, you are learning the theory of your assembly language. That's why you need to know all of this. It is not going to be like direct question asking you what is integer constant, but you need to know how the format, in terms of the format. I want to go to the specific thing questions. Okay, I think okay. the most important because it is under part B is your mana tadi slide dia your bukan kat module 3 how you put into your stack this one. Okay, this kind of question normally saya nak lukis. Normally you biasanya nampak macam ni kan, stack you tu. Normally you will be given the value of your offset 000, 0001. So you tahu semua dekat setiap kotak-kotak ni, this is all the box. You know basically what is the address or offset. Tapi dalam contoh ni, in your pages 54, as I mentioned, masa saya ajar you all, if you still remember, bila saya dah full screen baru nak masuk. Doi. Sekejap Muiz. Tadi lagi seorang. Okay lah, saya tak nak buat full screen lah. Saya draw je lah dulu kat sini. Okay, contohnya you ada, sekejap saya kecilkan dulu part sini. Tak boleh ke? Tak boleh nak tarik dah. Aduh. Okay, normally kan macam you punya example previously, you tengok our example we teach you like this. Biasanya kita tengok macam ni, so kita akan nampak satu-satu. This box is for this offset, this box is for this and this. But when you come to this example, at the class also I already explained. Mana dia pergi tadi? Okay ni, this one. You tengok this offset, this one is 000 and then suddenly it is 004. You need to know this is for this box. And then after that is continuous like this. 002, 0003 and dia continue balik pergi ke sini. It's going to be continuous and goes here. Then ini adalah 0004, value dia per, and then this one is 0005, 0006, 0007. In your test tu, dia tak akan keluar macam yang tadi mana? Because you need to fill in, isn't it? You need to fill in directly in your e-learning. Dia tak akan keluar macam ni. It's going to give you the picture of the box going to be in bentuk macam ni. So you need to know. Alamak, tak boleh nak delete pula kalau lukis kat sini. Aduh. So you need to know how to understand this table. For yang tahu tu, sebab saya dah explain dalam kelas, for yang tahu tu dia tahulah senang lah nak isi apa ni semua kan. But for those yang masih tak tahu lagi, if that question will coming out dalam bentuk macam ni, dia adalah continuous. Dia bukan semuanya 0000. Dia adalah 0001, 0002, 0003 dan pusing balik dan sama seterusnya. And for your test tu, selalunya yang saya tengok they going to give you initial value. Contoh dekat sini dia akan bagi tahulah your address, you punya let's say your address of your EAX. Contoh je your address is starting with your initial value 1110 contohnya, ataupun the address starting with this. But yang saya nampak, it's not giving you value yang mudah. Diorang bagi dekat sini macam 7 contohlah, tapi dia panjang, maksudnya 4, adalah kat sini 01 ke. So dari sini you kena pastikan because it's going to be like +1 and then you need to update into your address. You're going to update into your address. You're going to see this one will be 017F. Lepas tu apa? Takkan G pula. So you need to know also your hexadecimal number. Jangan lupa lepas F is going to be 1 balik kan? 1 kat sini akan jadi 8. Betul tak? Saya pun tak ingat dah. So please make sure in term of addressing your offset also, you going to play around with hexadecimal value. Kalau siapa-siapa yang dah lupa hexadecimal tu, baiklah tengok balik. Sebab dalam part 2, it is because dalam part 2, you're going to fill in the empty space over here. You kena, if let's say you type 7 and then 8, dia punya answer dalam e-learning dia memang 7 dan 8. Tiba-tiba you letak 7 space 8. Without your knowledge, you terletak space dekat sini, jawapan you pun akan salah. Because yang read tu adalah machine which is your e-learning yang tengok. Sebab kita dah buat programming, this certain block, the answer will be like this. If you ada terletak space ke, then it's going to be wrong. Then you please make sure look into the answer carefully. And of course, same goes to your test 1. Kita akan letakkan example how you going to fill in. Contoh, please make sure you remember back what is D word, what is S word, what is byte, what is word and so on, because you need to fill it in. Belajar balik, look back how you going to fill in. Kalau dekat sini dia bagi you D word, dia bagi you punya value dekat sini adalah 1, 2, 3 H saja, how you going to put the rest? Of course you going to put 0, 0, 0, 0, right? And there is also question, I forgot what question. Dia dah bagi tahu you siap-siap. It's already informed you earlier in the instruction, or maybe some of the lecturer asking to put here. If your value dalam ni kosong, you need to type empty. So janganlah you biarkan kosong. Maksudnya tak ada apa-apa, you tak taruh apa-apa ataupun you letak kosong, also salah. You kena type perkataan tu. So please be careful, read your question carefully, and kalau ada instruction, dia akan bagi tahu how you going to write in this box. Let's say kalau empty, you going to type empty, you nak type lah empty dalam tu. Jangan sebab instruction tu you confuse, you tak letak apa-apa maksud empty tu. Saya pun macam tak berapa nak setuju juga, tapi that kind of question, kalau dia kata empty, you kena type empty, bukan put empty. Maksudnya dia akan bagi you if empty, you need to type. You need to type key in empty. Bukan maksudnya you key in empty, you biarkan dia kosong. So if you biarkan dia kosong walaupun memang dia jawapan dia empty, maksudnya tak ada apa-apa value dalam ni kan. You tetap salah. So you kena type empty lah perkataan empty tu. Tapi saya ada rasa keraguan sikit, nanti saya akan tanya dekat lecturer lain. Empty punya words tu macam ni kan. Dia bagi contohnya short form. Not short form. Lower case. Kalau you tiba-tiba letak EMPTY, kenapalah tulisan saya ni. Kalau you type E besar kat depan ni, salah ke tak? So saya nak tanya juga. So please make sure kalau dia letak macam ni lah you type balik, okay? So that is the one that very important. Kalau dia tulis semua short lower case, you type lah lower case. Kalau dia kata ada kat depan ni capital lot and also then after that lower case, you letak sebiji-sebiji. Macam mana arahan dia. Okay tak? That is the cons dekat guna e-learning lah. Tapi pros yang kita orang dapatnya adalah senang lah, tak payahlah lecturer marking. Walaupun saya tak suka. Okay, because I think what I want to see in my student is I want them to understand. Bila dia orang faham tu, so maksudnya diorang faham lah, diorang tahulah how to answer. But in term of nak senangkan kita but tapi susahkan student, sometimes student tahu cara nak buat but just because they put and key in it wrong, that is the system problem because system have limited. Itu adalah sistem, bukan macam manusia. Manusia ni boleh lagi organize. So itulah dia pros and cons. So that one thing that you need to focus, how you going to put into your stack. Cara dia juga, which is Little Indian, right? Mana tadi? Sini saya dah lupa lah. Alamak, hai. This one. Little Indian order. So how you going to put inside your stack is throughout your Little Indian order. Cara ni please make sure you look back. Cara ni please make sure you look back, try back how if let's say like this and play around with the offset value also. Try to change the value and play around with A, B, C, D, lepas tu tukar jadi apa, hexadecimal numbering. Please play around with hexadecimal numbering. About the value, that's what is also important. Your byte, your words, because it's going to give you, let's say it's going to give you a source code. There is a several source code, right? Like this. Several instruction, not several source code. Several instruction. So this first instruction is going to give you the word. Second, dibagi you byte. Then after that word. And then dia akan bagi and tukar-tukar. It's not going to be fixed like one byte saja. So when you nak masukkan dalam you punya stack tu, depend lah, tapi saya rasa we fix with this kind of stack punya block. You belajarlah, dua-dua you belajarlah, jangan you fokus kat satu saja which is this one. So please try to do this kind of stack box and this one. So when you want to put it inside, it is on the way of your Little Indian order. Belajar how to put it, and your offset numbers also sometimes it's not fixed given. There is also a question that you need to write it down. Yes. But saya dah tak berapa ingat dah. Semalam kita orang go through laju sikit. that is about module 3. And next week, I will also repeat again and specify which example, which subtopic that you need to focus more. And another hint is read your example and also your lab 2. Kalau yang tak buat lab 2 tu, yang kalau use bahagikan soalan 1 kawan you, soalan 2 you, soalan question 3 another person buat, then it will become with a problem, because there will be also technique which is you need to use it and apply, which is from your lab 2. Jadi lab 2 tu macam saya kata, buat je lah semua, walaupun each part tu you kena explain tu kawan-kawan you yang akan gile-gile, which is you swap while you explain in the video, but please make sure you do it all alone and together. Okay, sekejap before I continue. Nak pergi washroom kejap. Wait. Okay, sorry. Just want to share while I go to washroom, I nak share satu benda. You know UTM student. Kalau you adalah UTM student kan, kenapa tiba-tiba tertukar kat sini? For UTM student, kalau nak enter UTM, maksudnya untuk student perdana ni, you kena ada pointer yang tinggi, you nak kena defeat, right? For MJIT, diorang punya student normally marks diorang kurang, pointer dia kurang. Same goes to space. So the standard tu nampak sangat beza, supposedly. Nampak sangat beza. Waktu saya ajar space last semester, when I teach space student last semester,
And my friend teach MJIT student, we can see the rank. Alhamdulillah. Okay, we can see the rank. Selalunya student space ni dengan student MJIT ni, diorang punya result tak okay. Sebab diorang macam kadang-kadang matematik diorang pun Allah hai nak tambah tolak pun macam susah. That is the true about space and MJIT student, but tak semualah, saya tak cakap semua. Sama juga UTM student ni tak semualah bijak pandai macam tu. Tapi kalau ada contohnya 10 section, if it has 10 section, last time for digital logic, section perdana semua top. Maksudnya semua dekat atas. Same goes to last semester, my section 2 selalu dapat ranking yang pertama, kedua macam tu. Then saya ajar space walaupun section 2 ni, section perdana ni sama kelas dengan student space. Sama kelas dan saya selalu fokus dekat student space ni. Saya akan WhatsApp diorang tanya okey ke tidak. Even dekat test pun saya call lagi, cepat masuk test semua macam tu. Diorang saya tak faham lah kenapa, padahal diorang berbayar tau. Then you can see walaupun kelas yang sama tapi student perdana ni selalu dekat atas je. Space ni Allah nak cakap cepat-cepat cukup-cukup makan macam tu lah, asalkan pas. Itu yang diorang aim selalulah. Saya tak cakap semua nanti kan ada yang salah faham pula. So apa yang jadinya sekarang ni dalam COA subjek, saya rasa macam bila dalam kelas tu saya buat sama macam you all, right? I did a similar which is I did similar which is I buat extra exercise, I do exercise together. Lepas tu saya akan pick student-student yang ada and try to answer. Set list satu soalan pun lama sangat. That's why kelas MJIT, kalau student space ni saya ada 2 jam je kan satu kelas kan. Satu hari ni macam saya petang nanti kelas MJIT, it is from 2 until 5 tau, 3 jam. Kelasnya 3 jam dan sangat susah walaupun satu soalan. Contohlah if let's say I give you question last time dalam calculation kan bab 1 dengan bab 2 tu. Mana example ni? Tak jumpa pula. Ni chapter 5. It's okay. So kalau dalam satu ada example macam ni lah, I pick someone. Kalau nak tunggu sampai kesudah tak akan dapat jawab. So saya akan proceed dengan example 2, tanya soalan orang student lain. Walaupun sebelum example 23 ni, I give already the example sebiji totally similar example. I will macam explain slow. Macam tu lah. 0 is what? 0 is no. Saya kena ulang beberapa kali supaya diorang faham. Tapi in term of bila saya macam alamak mesti diorang akan dapat teruk ni. Sedangkan example aja pun tak boleh buat. Macam mana lagi dengan test sebenar. But I was shocked, most of them dapat markah tinggi. Ada yang dapat 20/20 for part A. You tanya diri sendiri ini student MJIT tau. As I mentioned, diorang punya macam nak kata intelligent tak kurang lah. Tak adalah nak cakap tak pandai. Masuk universiti semua pandai lah. Tapi how they try to afford. You compare lah dekat diri you. Siapa yang tak dapat markah penuh tu you tanya, you ni student space ke? Ataupun student perdana? How you organize your time? Macam mana budak MJIT boleh dapat markah tinggi? Same goes to part B. Tapi mostly part B diorang pun mostly dapat rendah. Tapi I can see some of the student sangat macam mana nak cakap, lagi bagus daripada student perdana sebab okay, bila saya habis kelas, when I finish off the class, mesti ada student yang tunggu. Sebab they don't want to ask in class, I guess, because diorang malu ke apa, saya tak tahulah. Diorang akan tunggu and then diorang akan tanya, okay, saya ada masalah sekian-sekian. Dan student yang pandai ni, saya tengoklah ada dalam 2-3 orang, dia akan tunggu juga bukan sebab dia tak faham. Dia tunggu sebab dia nak tolong untuk jawab. Betul. Last time kita orang ada masalah dengan lab 1, masalahnya installation je. Kita orang buat bersama. We did together. And then this one student perempuan ni, dia boleh buat several, but suddenly tiba-tiba dia kata dia tak boleh compile. Nak step by step tu tak boleh. Alamak, saya dah lupa lah kenapa. Tapi sebenarnya when dia open, dia tak compile the ASM file yang dia punya tu. Bila dia tukar tu, dia akan compile lain yang dia compile. But this one student ni, saya rasa from Indonesia, dia duduk dekat dalam tu, kita orang buat sama-sama. Maksudnya I try buat, I share my screen and then the girls yang ada problem tu pun try buat and another student also try buat. Macam saling tolong lah, membantu. That is spirit yang bagus. So sampailah kita orang ambil masa yang lama, dekat 1 hour jugalah, barulah kita orang perasan dekat atas tu baru kita nampak dia compile benda yang lain. Walaupun kita open this file, kita open, kita klik, kita compile that following file, but rupanya dia compile lain. Saya dah tak ingat macam mana kita orang ubah hari tu. So dekat sini nak cakap, walaupun diorang punya ranking, kalau nak cakap dalam you punya pointer, they are quite low and semua lecturer kata macam MGIT tak apa. Diorang memang performance diorang tak okay sangat. Okay, budak space tak apa. Macam tu, macam diorang tahu which is they have low in result, macam tu lah. But I can see when COA, I tengok markah dia, I selalu cakap okay tak apalah, nanti kita tengok result macam mana. Then mostly of them banyak yang dapat good. And if you compare, I guess 2 or 3 student memang sangat brilliant. Diorang punya programming lagi hebat. In term of programming, lepas diorang dah macam expert. Although saya baru bagi lab 1, tapi diorang dah guna macam-macam dekat dalam Visual Studio tu. So tak payahlah, janganlah macam tunggu okay, kau adalah lecturer, sepatutnya kau lah ajar macam tu. You punya mindset tu tolong tukar. Sekarang ni student macam tu. Dulu kita orang ni, ada seorang student ni yang cakap dekat saya ni respon WhatsApp. Saya ni respon WhatsApp lambat. Sebenarnya masa tu student tu bagi kat saya WhatsApp waktu cuti. Tapi saya dah always remind you, kalau saya tak balas, you boleh je politely remind me again dekat dalam group WhatsApp. Saya ada PM tak nak balas ke, cakap je lah elok-elok, ataupun saya ada PM boleh tak balas ataupun tengok. Sebab tak semua saya boleh tengok WhatsApp tu. Saya ada cakap saya memang ada masalah dengan WhatsApp. Mungkin you boleh tukar cara, you boleh email ke. And satu lagi, itu adalah student sekarang. Cuba fikir waktu kita orang dulu. Waktu kita orang jadi student, kita orang tak ada WhatsApp ni, nak message lecturer pun takut. Kita orang cari lecturer, tunggu dia dekat bilik. Tapi memanglah you all tak boleh sekarang ni kan, you tak boleh come to UTM and then meet us, but then you need to WhatsApp. Tapi in term of polite lah, kita tak adalah nak push lecturer ni ajar macam ni. Buat kita tak faham. You sendiri ada you punya task, you adalah belajar, but tolong jangan jadi negative human being. Jangan negatif, you asyik nak blame orang macam tu, macam ni. You fikir diri you bagus. Macam tu lah. So, dalam kehidupan kita ni, sekarang ni zaman muda memanglah you rasa macam tu. Bila you dah tua ataupun you dah dekat tempatnya baru you rasa orang ni sudah positif sikit. You selalu tengok quote yang akan cakap remove negativity, remove negative energy, smallkan circle you. Itu semua orang-orang tua yang keluarkan ayat ni sebab diorang dah berpengalaman, dah lalui. Nanti barulah you punya darah muda you tu turun, baru you cakap okay, we need to be positive. Saya selalu cakap ke anak saya, dia punya budak kan, marah dia macam mana bila kita cakap sembahyang terus berubah muka dia. Ataupun suruh buat sesuatu terus berubah muka dia. Saya cakap kat dia, kalau rasa tak puas hati kat dalam diri tu, cakap kat diri, sabar. Belajar perkataan sabar. Fikir benda yang okay, aku adalah lebih ni. Mungkin keadaan macam ni, tak apa. Kalau mungkin lecturer tu terlupa benda ni, okay, saya boleh remind dia elok-elok. Lepas tu ataupun tak apa, disebabkan itu, fikir secara positif, you tukar you punya mindset. Oh, lecturer tu tak boleh jawab soalan ni. Tak apa, saya akan buat sendiri. Maksudnya positifnya you gain dapat peluang untuk you belajar. That's why pusing jadikan positif. That's why saya tengok budak MJIT ni, dia orang although dia pandai tapi dia help other student. That's why tiba-tiba saya pun shock, ramai yang dapat markah penuh and dia part B also similar je lebih kurang dengan markah you all dalam part B. Itu je lah saya nak cakap. Sebab saya rasa, saya ingatkan diorang ni akan dapat low marks. Ada yang memang betul-betul lemah tapi nampaklah diorang punya effort tu. Bebel sekejap dah lama. Okay, now I'm going to continue apa saya conteng kat sini ni. Okay, if you check you punya part module 5. Sekejap If you check your module 5 in your e-learning, I already upload several. And of course, I don't like and I don't prefer just on video. If you have problem, you tak faham sesuatu, you can ask me. Lagi satu saya nak cakap, saya ni if you are my student previously, saya sangat-sangat fleksibel. Saya lebihkan student. Kalau you nak cakap apa-apa, saya memang lebihkan student. Saya lebih faham keadaan student sebab saya pernah jadi student. So that's why kalau ada student tu buat effort sikit pun saya akan selalu cakap, tak apalah, nampak tak dia orang punya effort tu. Macam tu. Saya akan always help my student. Kalau you kata, apalah lecturer ni tak balas pun pasal lab. Saya hantar lambat contohnya, lecturer ni marah ke? Tak, jangan sesekali ingat saya akan fikir negatif cuba buang benda tu. Saya ni selalu sangat remind kat diri saya supaya fikir positif. So kalau misalnya you lambat, you ada bagi reason apa-apa, saya tak pernah fikir negatif you tipu ke, you apa ke. Dan saya even last SEM untuk digital logic saya akan terima. Saya akan check, alamak student mana yang kosong lagi, cuba tanya dia orang. Saya akan minta hantarlah. Saya kata, itu dah final exam ni dah sepatutnya dah keluar markah. Markah dah keluar tapi saya nampak you tak hantar tu, you tak hantar ni. And then student cakap, okay saya terlupa, saya tak sempat. Tapi kenapa sebelum tu tak bagi tahu? Kalau lecturer lain, ni dah final exam, dah keluar markah, tiba-tiba baru kau nak hantar. Mesti dia orang reject. But saya pergi cari student-student tu, saya kata hantar je lah. Walaupun contohlah dia tak sempat buat ke apa, saya kata yang penting apa je you boleh hantar, you hantar. Dan saya akan tolong bagi markah. As long as saya can help my student. So hidup tu kena positif sikit Saya tak tahu dah dekat mana saya semalam ni sebenarnya. Okay, now we're going to continue our module 5. Saya akan continue untuk habiskan. Kejap saya cari saya sampai mana semalam. Mapping instruction. Batch operand. Okay, this one is semua belum lagi. Okay, this I already cover but I just uploaded into YouTube. Satu lagi saya tengah combine. That's why saya tak share dekat e-learning punya link. Tapi kalau you tengok dekat YouTube, some of that I already upload. You can view it. Kalau siapa yang tengok saya punya YouTube lah. So over here, we have covers until several. You can see our last topic is 5.6. Okay, 5.6 under microprogram, and I already touched until microprogram control. This video I still in combining. Okay. In our module 5, I already give all the video until 5.5 from 5 form 1. And please make sure if let's say you have problem with all the instruction, explanation, you can always ask me. And I just try to finish first this module 5. Later on, we will do some recap, which is we're going to look into all the example inside. Macam example ni, this one I already done. So we will discuss together in class. And by next week, what will I do in our class is I'm going to do totally in our test 2. Kita bincangkan what we need to do. Maybe there is also past year question, we can discuss it together. And also lab 3. If you check the lab 3, there is a folder lab 3 in your e-learning. I already uploaded. Maybe don't wait for me. You can try to have a look inside. There is 2 files. One is instruction, what you need to do for your lab 3, and another one is lab sheet on your lab 3. Okay, over here I already covered the video, and that's why I'm not going to touch again. I will just continue. Okay. It's okay lah, sampai sini je. Aku kata I buat je semua sebab masa panjang lagi kan. Tadi 5.6. Okay. The overview under our microprogram control. You dah selalu, you always heard about CU, which is your control unit. And you already know also, for those lah, saya tengok tak ramai pun yang tengok video tu. I see only few of you watch that video. So please make sure you watch the video. So then you will understand what is microprograms. Kalau siapa yang tak tengok all this video, you tak tahu datang dari mana microprogram ni. The term of microprogram is approach to control unit. Design was organized systematically and avoided complexity of hardwire implementation. In recent year, microprogram, okay, dalam tahun-tahun sekarang ni, the backdated a few years back, we can see that a few makin berkurang that we use a microprogram in our use for a computer designer. And example is our Pentium 4. Kita ada beberapa Pentium before this. We have several Pentium before this. But most of the instruction are executed without using microprogram. So nowadays dah makin kurang. So most of it will use the hardwire implementations. So previously we used this microprogram. Now we have the hardwire implementation, but what we want to learn is basically the microprogram. A wide variety of techniques have been used for CU. Most of these can be categorized into two major, which is hardwire implementation and also your microprogram implementation. Ada dua je, software dan hardware. Sama jugalah dengan macam kita punya apa-apa submission. Kita ada hard copy, soft copy. Same goes this. This one is more on soft copy. This is a hard copy. If you want to compare with your day-to-day activities. Okay, now under hardwire implementation, you look over here, totally tunjuk je you dah faham. This one is digital logic lah doktor. Kita orang dah mahir sangat. Contohlah. So this is example of your sequential circuit. You already look into your JK flip-flop, your AND gates, NOR and so on. So hardwire implementation is using a sequential circuit. The control logic is implemented with gates, flip-flop, decoders and other digital device. So this is under use of hardwired implementation. So semakin banyaklah you akan gunakan you punya digital logic elements. Mungkin you punya processor Pentium 4 tu lagi banyak dia punya circuit. So agak-agaknya kita ada Pentium 10 contohlah akan datang. So all will be too many sequential circuit inside. We don't know what is happen movement toward on our next processor. What is the advantages? So it is fast operation. Sebab di connect kita tak tahu tiba-tiba dah keluar output. Small and also require less component. Memanglah we know already all this logic component is small. And you can see it is require less component if you can combine it together. That's why it's called as sequential circuit. And what is the disadvantages is need wire change. Contoh, example, if you want to change this one, or maybe you need to have a new program, you nak tambah adding punya program, you kena tambah dekat sini. Adding saya dah tak ingat dah macam mana adding punya tu, flip-flop. So you kena tambah. Then you need to modify your design. If the design has to be modified, sebabnya you kena tambah satu lagi and then you need wiring changes. So these disadvantages of using your hard wires. Now when you look into microprogram, in our daily life we have a pros and cons. Tak ada seorang kat dunia ni yang perfect. Tak ada apa-apa benda kat dalam dunia ni adalah perfect kecuali our prospect. Itu tak boleh nak cakap lah. Cuma semua memang ada pros and cons. Sama juga it's same to your, alamak sekarang ni iPhone berapa? 12 ke 11? Saya dah tak ingat dah, saya tak ikut iPhone punya generation. So iPhone 12U, if you compare dengan Samsung punya 10 code, saya bukan orang teknologi sangat, mungkin version 10 Samsung paling terkini. Note 10 ke Note 20 macam tu lah. So if you have, dia kata Samsung claim this phone paling canggih. The technology is the highest technology. Apple pula claim that this iPhone 12 is much more. Dia boleh zoom ultra 100 kali. Contohnya lah. So but dia ada dia punya pros, dia ada dia tapi dia ada dia punya cons. Maybe dia cepat panas, phone you cepat panas, your battery will drain faster and so on. So there mesti ada pros and cons, or maybe you can compare this and this. Will be a pros and cons. Samsung also maybe dia boleh zoom jauh juga, tapi mungkin you punya kamera is besar sangat. Dia adalah pros and cons. Same goes to hardwired and also microprogram. There is a pros and cons. Walaupun you dah cipta yang lebih baru, still there is something place that you need to improve. So need to improve means there is a gap and also disadvantages. The control information is stored in control memory. So under microprogram, you're going to store your control information in control memory. The control memory is programmed to initiate the required sequence of micro operation. Apa micro operation ni? Ini soalan yang student-student yang tak tengok video tu, dia akan tanya benda ni. Sebab kita dah bincang inside the video, what is micro operation. So, tak apalah, saya tolong. So let's say you ada source code, your program, you ada program. Last time you dah tahu in your program ni you ada beberapa line instruction. You ada declaration, you ada data, you ada instruction and so on in your program dalam you punya source code ni kan. So ada beberapa program and you already learn this single line is single instruction. Satu line ni instruction 1, instruction 2, instruction 3 and so on. So you going to divide it into instruction. Let's say single instruction. I forgot how the Gantt chart look like, but it's okay. You can see. So you ada lah, contoh ada 10 line, 10 lah you bahagi-bahagikan dia. So ni contoh instruction you. And if you look back, siapa yang dah tengok video also, then one single instruction ni dalam satu line MOV EAX 197 contohnya hexadecimal, dalam single line ni je sebenarnya you ada beberapa step yang you buat. Salah satunya you going to do a fetch. Apa tugas fetch? What is fetch will do? Fetch akan buat, you going to fetch the instruction first, and then you going to decode, and after that if necessary, if needed, you going to do apa perkataan tu I dah tak ingat dah. Nanti I recap back. Okay, now you will have another one is execution. Execute. After that you're going to execute. And you can also have the interrupt. So you're going to have also interrupt. Let's say there is also another one. Alamak, ini nama ni mesti saya lupa. Interrupt. Siapa yang dah tengok apa nama ni? Lagi satu. Then fetch ni kat sini nampak sangat semua tak tengok lagi ke? Ke saya dah terkeluar dari Gmeet? Tadi saya bebe-bebe sorang-sorang, tiba-tiba student saya WhatsApp, saya dah terkeluar dari Gmeet dah. Okay.
Ada.
Apa ni jawapan ni kat sini? Dia punya bentuk fetch, lepas tu execute. So you going to do this part. Okay. And sometime only you will needed this process, and this one is your terminate interrupt. Okay, so after this, after you dah kata dalam satu instruction ni you going to do all this fetch, execute, interrupt, you can also see your fetch ni apa yang dia buat, where is basically fetch doing. So there is also a few step under fetch, there is also a few step under execute. So all these step is called as micro operation. Adalah dia punya step-step dia. This one is instruction, this one is single instruction operation, and now is your micro operation. This step all known as micro operation. You can look back the video and you will know what is micro operation. Saya dah tunjuk pun. So, micro program also ada. There will be advantage and disadvantages. Advantages dia, system and any required change can be done by updating the micro program in your control memory. You just update your micro program punya controller saja. Mungkin you update your source code. You macam tadi for hardwire, kita nak tambah adding kan, additional operation, kita kena masukkan contohnya salah satu lagi full adder punya flip flop. Contohlah, you kena masukkan full adder, you kena tukar balik, redesign ataupun change your sequential circuit tu. You kena change your circuit. But kalau in your programming, in your microprogram, dalam programming, you nak tambah adding, you tambah je lah dekat situ. Yang lain tu tak adalah apa-apa yang berubah sangat pun. So that is on the advantages of microprogram. But disadvantages is it's slow in operation. Dia kena step. Walaupun you nampak you just debug, keluar answer. Because it is in micro or micro and nano, maybe second. So dia punya tu dalam millisecond ke microsecond ke nanosecond dia punya proses kat dalam ni. Tapi dia actually adalah slow because actually your computer is reading it one by one, single line and single line. And you are required to have more components by using your microprogram. So now you have already looked into the advantages and disadvantages. Siapa yang baru masuk, terkeluar ke tadi? Okay, micro operation. So under micro operation, this one. To implement a CU as a interconnections of basic logic element is not an easy task. Mungkin you kata macam, oh senang je you type the source code inside and you already have a new interconnection to your CPU, your CU. The design must include your logic sequencing through your microprogram for executing your micro operation, for interpreting opcodes, and for making decision based on ALU. Flag. It is difficult to design and test just a piece of hardware. The design is relatively inflexible. For example, it is difficult to change the design if one instruction or one wishes to add a new machine instruction. So tadi kalau kita compare, if we compare with microprocessor and also our hardwire ni lagi susah, and it is hard rather than microprogram. But actually in microprogram also it's not an easy things. You need to do something which is quite difficult, especially in terms of design and test for your hardwire when you are related to your micro operation. So disadvantages of your hardwired implementation is listed over here. And that's why this is the problem when you have the hardwired. And that's why you will come out with a solution. Setiap masalah ada penyelesaian. Every problem there will be a solution. Sekejap ya. Okay. So every problem there will be a solution. So the solution and alternate of your hardwire control unit is your microprogram control unit, in which your logic of CU is specified by your microprogram, or we call as a firmware. Firmware over here, that's why this is the solution for your problem. Microprogram consists of sequence of instruction, which is your micro operation, in your microprogram language. Dia punya anak-anak task, another task tu your micro operation in your microprogramming language consists of sequence, because you going to do it step by step. It is called as a sequence. Kalau tak sequence tu, you can do it any task, maybe 1, maybe 3. A microprogram control unit is relatively simple logic circuit that is capable for sequencing through micro operation and also generating control signal to execute just micro operation. So how we use the concept of microprogram to implement a control unit? So you dah tahu microprogram is the solution for you, but how you going to implement it in your CU? Consider that each micro operation you need to consider the CU is allowed to generate a set of control signal. This is one of consideration that you need to do for you to apply the micro operation, micro programming in your CU. For any micro operation, you punya micro operation, each control line emanating from CU is either on or off. This one is logic, digital logic. You already know. On is similar to 1, off is 0. So we should construct a control words, which is micro instruction, in each bit representing one control line. So the PS, then each your micro operation will represent by a different pattern of 1, 0, 1, 0. After this, you're going to look into the example. This is the example. For fetch instruction, as I give you, fetch is another one of operation in your single instruction. After this, you're going to have execute and also your interrupt. So one under fetch, there are many micro operation. Walaupun dia hanya nak baca single line ni je, MOV EAX tadi berapa 197H. Contohnya dalam satu single line je ni, dia ada banyak which is under control unit your micro operation. What you going to do hanya dalam satu single line. Tapi kalau you press your F11 ni, step you you tak nampak apa-apa pun, betul tak? Because you will see directly you get the output, So for fetch instruction, there are many micro operation. If you have given with different kind of micro operation value, the fetch instruction also will be different. Dalam you punya fetch, let's say you going to have several micro operation. You punya micro operation. Later on you will see what is the operation that available in fetch, execute and so on. Previous video already give. Okay. Your micro operation 1, let's say 2, 3, 4. Yang ini I just give you example in the one that you can see. Maybe yang ini is going to do a positive, which is adding. This one is doing subtracting. This one is multiplication, division. So of course it's not going to do this, okay, in fetch. Fetch is only do the education, fetch and also the decoding. So just give you example on the operation. If let's say you have 1010, this one 1001, oh okay, 1001, what you're going to enable on your control unit is going to enable only the operation for addition and also your division. So control unit send 1 and 0 signal to your micro operation. Control unit ni yang akan instruct. So if let's say you ada 0, 1, 0, 1, you akan, control unit ni akan assign your fetch into do subtracting and multiplication only. If you have all 1, that your control unit send instruction for your micro operation to run it all. So that is the difference between whatever control unit given to your micro operation. So micro operation, you can see this is your control memory. Inside your control memory, let's say you have this one is fetch, this one is education, this one is termination or interrupt. You have inside your control unit, dalam, it is inside your control unit. And your control unit inside your CPU, you have also your ALU, right? Saya asyik tak reti je lukis ALU. And then you have a register. And you can see over here example routine, fetch cycle, execute cycle, interrupt cycle, and you have addition, movement, subtracting, multiplication, division. Ni dalam you punya micro operation ni, contoh. This just example, okay. So what you're going to do is this control unit yang akan instruct what is the design that routine 1 will do, what is control routing 2 will do, and same goes to routing 3. So that's about your explanation under your micro operation. Now you going to see your microprogram control unit. You're going to go deeper and deeper. Microprogram control unit, because you cannot see it basically in a real life, which is when you are using your Visual Studio, you cannot basically see what is happening inside. So simple description, the set of micro operation is stored in your control memory. Same goes to here. You're going to store your micro operation inside your control memory. The control address register contain the address of the next micro operation to be read. Mana tadi? Okay. You're going to have the next address to be read. When micro operation is read from your control memory, it is transferred to your control buffer register. So this is your control memory. Your control address register will be putting in this one, so that you know the next micro operation that you're going to instruct. And after that, when your micro operation is read, you dah buat operation 1, operation 2, operation 3, you're going to transfer it to your control buffer register. That is the architecture of your control unit micro architecture. So this one you can see, this is fetch cycle routine, indirect cycle routine, indirect fetch, and then you have execute, you have interrupt, you have indirect. If needed, your operand are using the indirect, enable the indirect, then you can also go to the indirect first before you go to the execute. But you can also directly from fetch to execute, and after execute, you can also have the interrupt. Maybe your computer is having low battery, you stop, or maybe you type the control C in your computer, it also can interrupt, and it will looping until the end of your source code. So figure shows the program routing could be arranged in your control memory. So you have fetch, indirect, interrupt, execute, all these are routing. Then you can see this one, jump to indirect or execute. See whether you're going to indirect or you're going to execute. It's already give you the address for next micro operation. Then in your indirect, jump to your execute. From your execute, you can see also you're going to have interrupt, jump to fetch. See this one, interrupt, jump to fetch. And then for your execute cycle beginning, jump to opcode routing. Maybe you can also jump directly to your fetch to begin. And end routing, fetch or interrupt, add routing, what is this? Maybe there is also several other operation that might also involve, and until you finish. So this is the organization of your control memory. So dalam your control memory, this is the organization look like. The micro operation in each routing are to be execute sequentially. You kena execute dalam each. Contoh, if in this fetch, for 1, 2, 3, you kena execute 1, execute 2, and then execute 3 sequentially. Dalam indirect, contoh, example, you can jump to your fetch tanpa you lalu sini, tanpa you lalu execute first, tanpa you lalu indirect, ataupun tanpa you lalu execute, you can jump to interrupt first, to indirect first. So you can jump ataupun mengecualikan you punya operation, but inside your operation you need to do it in sequence. So this is already given you a note. Each routing end with a branch or a jump, which is the one that you will end with something that inform you or instruct you where you need to go after this. So what is the address next that you're going to go? So this is the end of each of your routine. This is routine 1, routine 2 and so on. And instruction indicating where to go next. Ni lah where to go next. Okay, now you can see this is the functioning of microprogram control unit. You have the instruction register, decoder, control address register, control memory, control buffer register. In your previous, you see this one. And with this, you see this figure. In your microcontrol unit, you can see all of this inside this. Now you can see there is a lot other on your control unit. Last time you just see in a single control unit, you tak tahu pun, you don't know what is inside. Now you already know. Later on you will see how many input, how many output. Actually there is a lot of another input, tapi tak nampak dalam gambar ni. Later on you will see. You have ALU. Oh, okay, kat sini. You have your ALU, you have your flag, you have the clock, all of this input and also instruction register. Dah ada kot dalam previous subtopic. And your output will be only two, which is control signal within your CPU or control signal to your system bus. So you need to know the picture and organizations of your control unit. How many input? What is the type on, what is the elements of your input? What is the element of your output? Sekejap Okay. Siapa ni? Sekarang Assalamualaikum doktor. I lost network connection on my laptop again. Kindly share the QR code for attendance here. Dia tak nak masuk kelas ke apa? Dah terkeluar, lepas tu dia terkeluar terus. Aduh, hai. Okay. So you can see comparing this figure with the previous picture, you can see simple description. We see the control unit still has the same input. IR, ALU flag and also your clock. So you have ALU flag, clock, your instruction register. And the output is your control signal. So there is these two. First of all, what you need to do, what happened inside your CU. First, you're going to execute an instruction. You ada instruction move, tukarlah BX 4000. Contoh, this is one single instruction. You're going to execute this instruction. What is happened is the sequential logic unit issues a read command to your control memory. Dia bukan terus you execute, but it will instruct first the read to your control memory. So sequential logic ni akan instruct dulu. Second, the word whose address is specified in the control address register is read into your control buffer register. So you're going to, your control address will be in your control memory and control buffer register into your control buffer register. And third, content of the control buffer register, content dalam ni inside this generate control signal. It's going to generate control signal. And next address information for sequencing logic unit. So satunya is going to be next address control and it's going to have a control signal. There is two type of control signal which is within CPU, dalam CPU tu saja ataupun the control signal to your system bus. Next is the sequential logic. Ini balik, you're going to look again. You need load a new address yang baru into your control address register band OS next address information from your control buffer register and the ALU flag. Bila you dah, contoh you execute one, right? Then daripada address you 00100, then it will change to 0101. Dia akan update kat sini, dia akan baca your next line step, what is in your stack, the value and so on. All this happen, you can see, all of this happen during one clock pulse only. That's why you cannot see in your eyes, using your eyes. The last step just need need elaboration. You can see over here, this is your ALU and also your next control. This one. Next address decision. How you going to see your next address decision? Because you are the next address from your control buffer register inside your sequential logic, but you also have another element, your ALU flag yang akan will trigger your next address. So depending on the value of ALU and also your control buffer register, one of three decision is made. First, get the next instruction, add 1 to your control address register. Second, jump to next routing based on jump micro operation, which is you're going to load the address field of your control buffer register into your control address register. And third, jump to machine instruction routing, which is you're going to load the control address register based on your opcode in your IR. So that is under what happened basically inside your CU when you want to execute one in single instruction. So you can see it's all happened in just one clock pulse. Now you're going to see the address generation. Another viewpoint is to consider the various way in which of the next address can be derived or compute. So you're going to see it can be divided into explicit and also implicit. What is the element under explicit? What is element under implicit? So the address is explicitly available in your micro instruction, while this implicitly require additional logic to generate the address. So you have to fill for explicit vice versa mapping for your implicit, unconditional branch for explicit and additional for implicit, and last one explicit in is conditional branch and also residing control for your implicit. Under micro instruction are stored in your control memory in group, which each group specifying a routing. So what is mapping? This one is you look into your implicit. Each computer instruction has its own microprogram routine to generate the micro operation that execute the instruction, which is your one single instruction. Mapping is the transformation from the instruction code bits, your opcode, to an address in control memory where the routing micro operation is located. Let's say you have this kind of instruction. Then this one is you going to transform using a mapping to an address. You tengok dekat sini, then your address is maybe starting at 510A contoh. Let's say this is your address. So this is in your control memory where your routing or micro operation are located for this instruction. Mapping is one of several implicit techniques that commonly used. So this is the common technique that normally used in your programming. This figure showing you the opcode to the how you're going to transfer your opcode to micro instruction. You punya programming tu how you going to change to your micro instruction. So you have, let's say over here you have an operation and MOV, you have the opcode and operand. Yes. This one is your opcode and then your operand. This is one instruction. You can see over here, this is one instruction. You're going to convert this opcode to your micro instruction. Let's say first you have fetch, initiate, then whether it is addition or maybe subtraction routing for your codes inside your control memory. In the mapping instruction, again, mapping, you can have two kind of method. First is which is direct mapping. You already given direct information about the address. And another one is using ROM to specify mapping function. Maybe you put something else which is indirect on the address. A specific type of branch exists when micro instructions specify a branch to first word in control memory where a microprogramming for an instruction is located. So you need to remember there is two method that you can apply for your mapping instruction. Under direct mapping. So this one is direct mapping. Your odd. Maybe this is addition. This one, because we don't know the machine language, right? Maybe add is 1011. Sub maybe 0111. Okay, contoh. Example. So your opcode and then there is address or your operand. This one is your single instruction. Then your opcode is showing it is a 1011. If you are doing a direct message, your mapping bits already given 000. In the middle, you don't know. So what will happen is your micro address will be directly, because it's a direct message, directly be putting inside this one. You will take it down, this. So it will directly put into your micro instruction address. This is the mapping from instruction code. This one instruction address. this is how you're going to do it. Let's say you will give it the example, this kind of example. You were given the opcode 1011. So if the mapping bits are 0, XXXX over here, if using the direct mapping, you're going to bring it all down to fill in your micro instruction address. Then this is your new micro instruction address. It is too direct. It's easy for you to apply and understand. Over here under example 22, mapping the instruction code to micro instruction address. If the opcode byte is 1001, you can always directly bring it and change, putting it into your micro instruction address. So it depends on what process of operation for your opcode. Here is given the opcode instruction. Kalau you were given this kind of codes, you can see over here for adding it is 0000. For N it is 0001. LDA, what is LDA? Load data 0010, STA, BUN, all are given, and this is your mapping bits. I guess I need to find the table so that we can understand much more on the numbering. Basically, in question, it will give you the opcode instruction. So then you no need to memorize the tables. So when you have this kind of opcode instruction, maybe your operand will just put add. So you know add is 0000. How you going to apply in your mapping bits? Let's say in front is 10 and behind is 010. You just put in like this. So this is the one that you add inside. Similar your add routing, you just put 0000 and is 001 until the end, depending on your opcode instruction. This is direct mapping. Using your ROM, your ROM, to specify mapping function. So let's say this is your opcode, and you have your operand, and this opcode is already mentioned. I don't know what is the operation, this one 1011. It going to send it into your ROM, your ROM. Your ROM, why you send it to your ROM? Because you want to specify the mapping function. Instead of you have direct. It's 13 hours. Now you're going to do your ROM specifying mapping function. That's why this opcode will send to your ROM, and then your ROM will decide how it's decide. It will send it to control address register, and after that control memory. The microprogram routing can be anywhere in your control memory, providing flexibility for adding instruction for control memory in a need rise. So you're going to learn how basically the flow. So the flow for the using a ROM. So this one will be going to the ROM. It will decide, and after that it will go to flow for your control address register, and lastly on your control memory. Micro instruction format. There is two kind of micro. I think there is another 20 slide to go, but it's already 1 p.m. Okay, later on, I will upload, as I already mentioned, I already have the video, some part for our 5.6. Mana 5.6 I tadi? Okay. For micro operation under 5.6, I already have several part, and I will combine with another video. So today video I will combine it. I think there will be two parallel similar subtopic. Maybe you can just, if let's say you already understand with the class, or you just keep my versions of recording, but I will just combine the video together until we finish module 5. There is another about 20 pages to go. So is there any question until what we have covered in 5.6 today? Okay, if there is no more question, let me check the chat. Doctor, does the video for the lab have to be on all part, or we can choose to do it for one part only? Since they are, Jivan, I already mentioned in the class, I guess. You have several question in your lab, but I ask you to pick. It's depend on you which question that you want to explain. But you need to remember, while you explain the video, all the member need to be participate. Saya nak dengar, I want to hear the voice for all members in that video. So kalau ada, if you have 3 members, 3 voice, 3 different voice. Takkan you punya suara sama pula dengan kawan you kan? So what question you can just pick and choose which one, as long as I can understand your explanation. Okay. So any other question? So it doesn't matter how many question or part. Yes. Kalau you nak terangkan, if you want to explain all also can. But if you want to pick only like part A and then part B, it depend. Jangan tak terang langsung pula.
Excuse me, doctor.
Okay.
We are going to present the question, or we have to record?
You have to record. You have to record the video.
Oh yeah, and submit on e-learning with the lab.
Yes. You need to submit PDF, one PDF which is your answer, and another one is the video which is including all the members' voice.
So we have to do meeting and record it, you like that?
Yeah.
Okay.
Okay.
So, madam, we need to like show our faces or no need?
It's okay if you don't want to show, but as long as I know, if 3 members, 3 different voice. Okay. Jangan pula you suruh kawan you lain-lain pula yang bercakap. As long as you have 3 different, which is 3 member. If 4 members, 4 different voice. So I know who is explaining. Sometimes in your Google Meet, you can record, right, with your friend. Maybe you don't want to open, because sometimes when you recording through Google Meet, dia punya, you going to see the faces is bigger than your the one that you want to explain. So it's okay if you did not show your face. For lab 2 only, okay?
Doctor, I still cannot see any submission link. So, can you please?
SCSR, isn't it?
Yeah.
It's okay. After this, I will directly try to check again. But SECR, I already done it. Please don't forget to put and write all your team member names in the report that you submit, although it is submissions individually. Okay. So if there is no more question, you can leave this Google Meet. I nak pakai link yang sama for next class. You can scan your QR code that I already provided in your e-learning. Okay, thank you all and please be safe. Bye-bye.
Thank you, Doctor.
Bye-bye,
Thank you,
Dokter.
Doctor.
Thank you, Dokter.
Selamat Hari Raya, Doktor.
Selamat Hari Raya, tak ada duit
Thank
raya.
you, Dokter.
Okay,
Tak ada Hari Raya.
dah upload tadi.
Miss, can I ask? Tapi can you stop recording first?
Oh, tak habis record lagi lah.
Okay, hi. Sorry, taking you some time. Okay, over here we're going to continue. I pick best position for me. Okay, if you look over here, this is your motherboard. In your motherboard, what you have, what element you have? One of it is your CPU. Inside your motherboard, you're going to have your CPU. Inside your CPU, of course, you're going to have ALU, and also your register, and another one is your CU, which is control unit. So inside your control unit, you have this red color called as a control memory. Oh, my mouse. Okay, inside your control unit, your CU, there is control memory. So for control memory, you have listed several of instruction process or instruction flow, which is your cycles. Let's say for this one, if you still remember, let's say we name it as a fetch, and inside the fetch you're going to execute a single instruction with several follow step. This is called as a micro operations, and your micro operations is called as routine 1 here, if let's say for example it is a fetch. And then you have a routine 2, routine 3, and etc. So this is example: fetch cycle, execute cycle, interrupt cycle. You can have the operations of add, move, sub, mouse, and also diff. So under microprogram control unit, so this is a simple descriptions for your micro operation. The set of micro operations is stored in your control memory. So that is the task for your control memory. It's going to store the set of micro operations. The control address register contains the address of the next micro operation to be read. You can also refer to this picture, control unit microarchitecture. When a micro operation is read from the control memory, it is transferred to your control buffer setting. So you have over here your sequencing logic. If you read it, then you're going to put it into and store it into your control memory. While you also can have this control address register to be put it inside your control memory, and lastly it will be the output from your control memory called as control buffer register. This figure shows that the program, which is your routine, which is not you are the one, but your program routine, could be arranged in a control memory. So you have this fetch, indirect, interrupt, execute, and then you have the process of AND, add, and etc. So you can see over here the micro operations in each routine are to be executed sequentially. So for the micro operations in routine, you can see you need to do it sequentially. This is 1, 2nd, 3rd, 4th, 5, and so on. Each routine ends with a branch or jump instruction indicating where to go next. Okay, this is just a theory basics for your process under your instructions. Okay, comparing this picture with our previous one. Alamak, mana dia? Okay, it asks you to compare, which is simple description. We see that the control unit still has the same input, which is IR, ALU flag control, and also output control signal. So you have the control memory inside your control unit. So control unit also have sequencing logic, also have decoder, and also control buffer register. So from here you can see also you have the input of your flag and also your clock. LU is supposedly outside. To execute an instruction, the sequencing logic unit issues a read command to the control memory. The word whose address is specified in the control address register is read into the control buffer register. The content of control buffer register generate control signal and text address information for sequencing logic unit. And also the fourth is the sequential logic unit load a new address into control address register based on the next address information from control buffer register and also ALU flag. So this is all about the flow. Basically, we already also looked into the explanation previously, only in terms of very specific sequence we need to memorize. all this happen during one clock pulse. This one I guess you already understand it. The last step just needs elaborations. The sequential logic unit load a new address into control address register based on the next address information from the control buffer register and the ALU. So if you look here, the last step need elaboration. Just listed need elaboration. Depending on the value of your ALU flag and also your control buffer register, one of these three decision is made. So you can have at least one of these decision. So first one is get the next instructions add 1 to the control address. This one also we already done, I guess, previously. And jump to new routine based on jump micro operation. So you will have J M P. You have the code like that. So inside here you're going to have like more loop. But if it's already finished, it's going to continue. So it is a jump micro operations. Third is jump to machine instruction routing. Load the control address register, which is CAR, based on the opcodes of the IR. Now we're going to go deeper and deeper, but mostly now it's just more on theory. So I hope that you are not feel sleepy while listening my video. While you are watching my video, maybe you can have a break to have a tea in the middle of my explanation. Your under address generations, you can see another viewpoint is to consider the various way in which the next address can be derived or compute. If let's say you can do that. Micro instruction address generations technique, you can divide it into two, which is explicit and also implicit. Under explicit you have two field, while for implicit you are doing mapping. Explicit unconditional branch, while mapping is additions. Explicitly conditions branch, and lastly for implicit you have the residuals control. So the address is explicitly available in the micro instruction, while require additional login to generate the address. So this is the one for your explicit and also implicit. More theory to coming in, more memorizing the terms are becoming more important in our 5.6 subtopic. So you can see over here your micro instructions are stored in your control unit. This is the repetitions info in a group, which each group specifying a routine. Each computer instruction has its own microprogram routing to generate micro operation that execute the instruction. You can see over here under mapping, the transformation from the instruction code, which is also bits opcode, to an address in control memory where the routing microoperation is located. Mapping is one of several implicit technique. So mapping is implicitly, you can see over here under implicit, you have mapping. So recap several times, as long as you remember, technique that commonly used. Now in this figure, it shows you the transformations of your opcode to your micro instruction. If you have here, you can see the instruction for your opcode. You have the additional routing. You can also see that several others process are doing like a fetch cycle routine, indirect cycle routing, and subtraction routing. So for this one, it is transformations of opcode to your micro instruction. So this is about your address generation. Now you're going to look into mapping of instruction. There are two methods basically for mapping basically on your instructions. So a special type of branch exists when micro instruction specify a branch to the first word in control memory where a microprogram routing for an instruction is located. So two methods, as I mentioned previously, there are two methods. First is direct mapping. Second is using ROM to specify mapping function. Direct mapping. The status bit for this type of branch are the bits in the operations code part of the instruction. So you can see over here, this one we already look if there is the instruction of 1011, what happened. But in terms of your micro instruction address, if you were given computer instructions, you can divide it into several, which is your opcode and your address in the stack. Mapping bits, it's given you 000. And if you want to create the micro instruction address, you need to get the mapping bit, which is 0 over here, for the MSP, and for your right side, which is your LSP, you're going to also bring these down. And at the middle, which is under your mapping bit, it's depend on you can see it is look like no which is X. So it's directly will send to the micro instruction address below. So it's going to be 0101100 for your micro instructions address. We have another example, which is mapping from instruction code to micro instruction address. So you can see over here, if let's say you were given the mapping bits of this for your computer visions, mapping bits for there is no, which is 0, and then but over here, if the mapping bits are 0, then if the mapping bits are 0 and then x and 10, you're going to bring it all down. What you need to change is only the axis over here, which is depending on the computer instructions above. Okay, I think this one is last example I will explain in this video. Later on, I will create another short video for you to finish the 5.6. So for this example 22, mapping from instruction code to your micro instruction address. So if the opcode is 1001, you're going to put into your opcode, and then of course you're going to have your address. Bit is 0 and 10, and in between you're going to have 1001. So all of this, I guess until this B using ROM to specify mapping function, I will cover. And toward after micro instruction format and etc., we're going to meet it and discuss it in our next video. So over here, this is the last subtopic for 5.5. 5.5. Okay. Using ROM to specify mapping function, one can extend the concept of direct mapping with more general rules by using ROM to specify the mapping functions. The bits of the instruction PD, the address of mapping ROM, and lastly the contents of the mapping ROM give the bits for the control address register. So this is how basically you're going to come up with the answer. So in this video, I'm going to touch until this part only. Thank you for your watching, and we meet again in our next video. Bye bye.